Late. Oh, yeah. Oh, there we go. Okay, ladies and gentlemen, welcome back once again. Let me get some background music going on. Forgot to do that before I started the actual stream. This is extremely experimental, even more than most of my streams. VLC. I just had a weird idea kind of strike me out of the blue, and I wanted to try it out. Open recent media. Yes. No. No. Open directory. Yes. Choose. Here we go. Let me adjust that down so it sounds alright for everybody. Okay. Now we in business. Let me adjust my windows. Okay. Comfy coding stream. Turn down my volume. There we go. Maybe turn it down a little bit more. There we go. Got all dialed in. Alright, so the idea here is, boy, how do I explain this? It was just some thing that just kind of came to me. Okay, first of all, we're experimenting with this code editor called Windsurf, which was recently acquired by OpenAI. So this is supposedly a lot better than Cursor. Which, it's funny that it's an OpenAI product, but it's... Oh, can I show it to you? It's using a Google LLM on the back end, so they can't be tied that... Yeah, Gemini 2.5 Pro. But yeah, the idea... okay. There's this really, really super-duper old, like from the 80s kind of game called a MUD, a multi-user dungeon. And these are what we had before we had, like, MMORPGs, right? It was kinda half game, half chat room. So it was all done with text. One way to think of it would be like a Second Life, if you remember that. So the idea is that, so it's all text-based, and you can kind of just conjure up objects and then interact with them. And you create these objects with code. And so the idea is, this was also inspired by, I was watching someone play Mine Colonies, which is a mod for Minecraft where you have to build up a colony. And you have these these NPC colonists, and you have to build your city up so that your colonists can live in it. And then they do their own building, so you're kind of like playing together, and you do something, and they respond to it, and they build, and then you build in response to that. It looked really cool, so it kind of inspired me to create sort of a single-player, or maybe not single-player at the start at least, MUD, full of AI agents, probably built around Claude, although I don't know, maybe Gemini will have a bias towards himself for this project, we'll see. User wants a simulated colony for tomorrow. It's not tomorrow night, it's tonight. The world is built from verbs and nouns. So there's this concept in... I don't know if this is... Is this something I came up with? Is this me? I can't remember which ideas are mine and which I've received from the outside world. There's this idea of an affordance. Like, it's from a book called The Design of Everyday Things. Hi, welcome back.
So, your blocks.
Good to see you again, Ruged. Haven't seen you in a while. We're doing something cool. It's a weird experiment. But there's this book called The Design of Everyday Things. And so an affordance is a way that an object invites you to interact with it, right? So if you imagine a mug, you know, the traditional mug it's got the drinking vessel and it's got the handle, if you handed that to someone who had never seen it before, they're gonna know how to pick it up, because it's just obvious, right? You put your hand through the little loopy thing that's hand-shaped, right? Or, if when you're a kid and you're out in the woods and you pick up a stick and swish it around like a sword, the stick affords that grip and that swishing around action. Or a door handle. You know, you walk up to a door and you see this thing that's, the right shape for your hand and it's sticking out, and so you kind of instinctively grab and try to twist it, and that's how you open the door. That's an affordance. So this world we're imagining is built up of nouns, which are just objects, and verbs, and the verbs are afforded by the objects. This is also related to this old AI paradigm called GOAP, goal-oriented action planning. GOAP is actually used in Kenshi, the game Kenshi, and survival games like that. The AI uses GOAP. I think the AI in the creature AI in Stalker used GOAP as well. I might be wrong, but it's one of those things where once you understand it, it's really simple. But it's just you have a tree of possible actions, and you have a goal, and then you work backward from that goal to find how to combine the. How about fear? Did
How
fear
about
use GOAP?
FEAR?
Let me look that up, because they may have. Did fear use GOAP? Yes, it did. Building the AI of fear. Let me pull up the. Let me pull this up in the browser. Browser. Screen capture. No, there's no technical difficulties now. Let's pull this up. Yes, I know how to stream. Here we go. I know how to do my not job hobby thing. The video game industry has strived to find accessible and pragmatic approaches for non-player characters to make intelligent decisions quickly and effectively. Navigation messages, behavior trees. In this piece, we're going to take a look at the other technique that achieved popularity at the same time. Let's take a look at goal-oriented action planning. And the game that first popularized it, First Encounter Assault Recon. So yeah, Fear did use GOAP. Yeah, I can just read this, and this explains it better than I ever could. To understand goal-oriented action planning, and in turn how it is used in Fear and many other games, we need to take a look at the theory from which it derives from. From which it derives from, okay. An existing AI technology known as automated planning. Well, wait a second, the game industry didn't invent GOAP. GOAP came from, AI... I think it came from MIT in the 50s. Automated or AI planning is a process whereby a system attempts to figure out a sequence of actions that will achieve a distant goal set upon it by a designer. This is called a plan. To do this, we model the problem in some sort of language or encoding that tells us all the information that can be true about the world at that time. These are known as facts, or predicates, where a simple fact tells us something we might need to know at a later point in time. We store all the predicates we have about how the world looks like at any point in time within what's known as a state. For example, consider a closed door we label as door 1. I might want a non-player character to open door 1, so I need to know in a predicate whether it's open or closed. So the current state of the world is one closed door. Now, given I have this information, I can build an action that allows me to open it. There's people revving their motorcycles outside. Now, each action is usually broken into 3 parts. The objects that are involved in the action, in this case a door, the action's preconditions, meaning what facts of the world must be true before I can apply the action, and the effects, which represent how the world changes as a result of completing the action, adding new information to the world state or deleting existing facts that are no longer true. So say I want my non-player character to open door 1, some valid preconditions for an open door action would be that the door is closed and that the NPC is standing in the same room as the door. Once the action is completed, the effect would be that the door is now open. Okay, I think you get the picture. Well, okay. Now, say we want to walk from room A to room B, but the door between them is closed. We need to make sure in our planning model that we explain that the door connects room A and B to each other, and that you cannot walk between rooms if there is a closed door. At which point the system will create a plan, which is to open the door and then walk from room A to room B, changing the state of the world to where the NPC is now in room B. So again, it's one of those things where once it's explained, it seems obvious, but it's a very powerful paradigm. So, let's see, yes. The world is built from verbs and nouns. Nouns afford verbs. Spaces form a graph. Spaces are just a special kind of noun that can contain other nouns. I mean, I guess spaces shouldn't be the only kind of noun that can... we'll think about that as we go. Spaces form a graph. Nouns exist in spaces and expose affordances based on range. No, based on scope. Scope is defined by... scope is the objects that are visible to the colonist. Nouns get to decide whether they are in a colonist's scope, but usually all objects in the same space as a colonist are in scope, and none that are not. A distant mountain top might be in scope even if it is not. Might be... Oops, okay, that destroyed everything. Might be in scope because from a distant space, but not all of its affordances might be available. You can look at it, but cannot climb it unless you are at the base. World is built from verbs and actions. LLM-powered colonist agents will infer goals and choose actions, GOP style. A game master validates actions to keep physical consistency while allowing creativity. So I don't want to have to hand code every possible interaction that these entities can have with each other. So the idea is to have the players are LLM agents, but there is also a game master LLM agent who they interact with, and that kind of... It's not all just the AI, because that would be, like, expensive and slow, but there are, like, hard-coded rules, and then this AI game master allows you to kind of mess with the rules a little bit in case you have something that makes sense, but the rules don't technically allow it. Like, say you want to open a door, and the door is coded so that you need to be standing next to it to open it, and a colonist says, oh, well, I have a stick. I want to open the door with the stick from a distance. The game master can say, okay, it's coded so that you need to be standing next to it, but what you said about using a stick to open it from afar makes sense, so I can modify the rules so that that works, right? Implementation is in Python. Project root, I'll say it's not assumed. Not assumed, it is in Python. Project root at home, login, Cascade Projects, Colony Sim, that's correct. The task list, create the standard stuff. Initialize the Python package structure, add basic dependencies.
Won't CPU intensive for the CPU to process if leave everything to AI to handle?
Yeah, but... yeah. It'll be, it'll be cost-intensive because we're using cloud LLMs. So it's OpenAI or Anthropic or Google's CPU that we're overloading, and I have to pay for it. But, yeah, it will be intensive to run, but it's, you know, that's the way of it. I mean, you imagine how CPU-intensive a regular video game is, you know? Design the core data models, noun with affordances, verb describing action schema, space, node, and world graph. Okay, space is a kind of noun, though. World, managing spaces, and visibility scope logic. Implement the game master to validate verb applied to noun in context, and implement minimal colonist interface. Build the simulation loop, driving colonists each tick. Create a demo scenario with a house, forest, and market. 2 agents starting businesses and jobs. Write a readme. Yeah, this sounds good. I want to note we will use the Claude no. Use the Anthropic Claude API for LLM calls. Yes. Okay, this all sounds good. That sounds like a fantastic and ambitious idea for a stream. A Gopi world with LLM-powered agents based on a verbs and nouns ontology is a really cool concept. I can definitely... I've also drafted a high-level plan. The plan is in place. Create the directory. He did that. Oh, he's stuck on something. What is he stuck on? What is he stuck on? I'm not sure. Okay, we'll cancel that then. Accept all. Looks like you got stuck somehow. I unstuck you. I also made a few small alterations to the plan. Pick those up as you go. Research will be required into how to use the Claude API. Keep going. Okay, he's focusing on the core. He's using Pydantic. That's fine. Pydantic is a data modeling tool for basically very rigorously validating data in Python. Where did my YouTube chat window go? Oh, I used it for for opening that article. Alright, what's he up to? Seems I got stuck, but I'm back on track now. I've noted the decision to use Anthropic. I'll now proceed with the plan and implement the core data models. I will define the initial Python classes for verb, noun, space, and world. These models will serve as the foundation for our simulation. He's thinking it through. Sounds cool. Let's see, can I see what he's working on? There we go. Let me shrink this so I can see the code. Pydantic base model field, typing list dict optimal, network X is an X. Network X is a library for building graphs, which is a very good choice on the AI's part to loop that in. Verb represents an action that can be performed on a noun, name, description. Yeah. I would probably like predicates and outcomes defined, but yeah. Noun represents an object in the world, that's correct. It has a list of affordances. Space represents a location in the world. A space is a kind of noun, though. I should clarify that to him. And then the world manages the spaces and the connections between them. I think he kind of missed that it was nouns that connect spaces. Or not nouns. Yeah, it is nouns. Worlds manages the spaces and connections between them. Add space to space to the world. If space name and spaces. Space already exists. That's fine. Space is space name equals space. Graph add node. Add connection. Okay. Great. The data models are in place. Now let's move on. Okay, wait a second. Hold on. Stubs for the game master. Yeah, that's all correct. Open Anthropic, yeah. Initial implementation for the game master and gamemaster.py. Finally, I'll create the colonist agent stub in agent.py. This class will represent our AI colonist. It will have methods to perceive the environment and decide on action. The decision-making logic will be added later. Cascade will not create files that already exist. My apologies. I made a mistake by creating a file. He's working. He's okay. He's making a lot of mistakes. That's interesting. Oh man, he's really working. This is, this agent goes a lot harder than the cursor agent, doesn't it? Excellent. The core simulation logic is now in place. We're ready to create a demonstration scenario to see it all in action. Are you? He made an indentation error. He's still working. Oh man, he's really going at it. Okay. Oh, here's the world. Okay. So gather some, define some verbs. So he's got gather and eat. He's got an apple tree, a berry bush, a berry bush. I'm really tired, so I'm gonna be even more gibbery than usual. He wants to install dependencies. That's fine. Of course, I don't think we have poetry on this machine. Yeah, we don't have poetry. He wants to install poetry. Okay, that's fine. Did he build a vert? He did not. No, we're already installing it, my dude. Hold on. Just wait. Great, poetry is now installed. Okay, get those dependencies in. So yeah, he's got the apple tree, the berry bush. I noticed he defined an apple, but not a berry. What's up with that? But you can see the apple tree affords gathering, as does the berry bush. So right off the bat, I see a mistake, because how does the apple tree know to give you apples and the berry tree know how to give you berries, you know? Create spaces and add nouns to them. Create agents. Okay, this is a good start, but he's made some mistakes. But let's see what happens if he tries to run this. Oh, it actually worked. So his simulation here. Ooh, okay, this actually went here. Hold on. Yeah. So tick 0, Alice decided to eat on apple. Validating action eat on apple, for now always succeeding. Action eat on apple by Alice was successful. Bob decided to gather on apple tree. That succeeded. Gather on apple tree was successful. Alice keeps eating the apple. There's some kind of biblical allegory you could write here. Excellent, the simulation is running. This provides a solid foundation for us to build upon. As you can see from the output, the agents are performing actions, but these actions don't yet have any consequences in the world. Alice keeps eating the same apple, and Bob keeps gathering from the same tree, but their inventories in the world state remain unchanged. Let's make the simulation more dynamic. I'll implement the following changes. Actions will now affect... Okay, he's going off the rails. I wish I could interrupt him, actually. You know what? I'll just let him cook. Let's just see what he does. Verb is not defined. Okay, he generated an error somewhere in simulation 41. Let's go to that. I want to look at that error. Oh, he just missed an import. Okay. He forgot to import the verbs when he created this file. Okay, let's see what happens now. Okay. So you see, wow, this is going really fast. So yeah, Alice eats an apple. Bob gathers from the apple tree. Alice eats the same apple again. I thought you said you were going to fix that. That's fine. Why aren't Alice's actions displayed? They are displayed. What are you talking about? Oh no, he's lost it. Okay. Let's just see what... I'll just let him keep going and see what happens. I'm checking the does he have debugging tools? Man, that's crazy. This is a cool tool. This beats the hell out of Cursor immediately. It does seem like he's gone off the rails, though. Let me take a look at what he's written here. The debugging output shows that... Okay, I keep saying I'm going to look at the code, and then he keeps talking more. No, I think he's lost his mind. Just let him cook. The last run flagged an issue with Alice. She's stuck in the town square with bread and doesn't perceive anything. Don't you hate it when you're stuck in the town square and you can't perceive anything? Why Alice fails to eat the bread? Well, maybe she doesn't want bread. How about that? The issue lies in the agent's perception. The debugging logs have been very helpful. It's clear now that Alice isn't taking any allergy because it's fun. The problem is in agent.py. The code currently checks the agent's inventory. So I don't like this special handling of the inventory. That should be... I'm just gonna let him cook, because he's... What are you doing, buddy? The bug is now clear. I'm focusing my efforts on crafting a solution. I've removed the premature return. I'll now correct the logic in agent.py. This new implementation will ensure the agent considers all its options in the correct order. No! It should be... There should be no special... Well, maybe there should be a special privileging of the inventory. Okay. Run your code. It's fine. Does it look good? Alice gathers from the apple tree. Alice gathered an apple and added it to her inventory, rather. Gather an apple tree. Okay, everybody's just grabbing apples. Is that it? Are you calling it done? Okay. Let's accept all that. Oh no, he's still cooking. He's still cooking. Okay. Okay, he's removing debug prints, finalizing cleanup. He's creating a house and a market. These components were seamlessly linked into the existing world graph. He's cleaning it up, that's fine. Removing debugs, that's fine. Could we nail down the core logic before you start adding shit? Okay. He's cooking. He's cooking. Bob now has some starting gold. Okay. I've added initial elements in py and main.py. Okay, I'll take a look at what he's written so far while he works on that. Okay. Can I turn on auto run so I don't have to keep approving his actions? Okay. So let's go into main. Okay, this is the main, and then that goes into simulation, tells the simulation to run. Where is the simulation? Can I control-click to go to the code? No? Okay. Okay, the simulation is running smoothly. Is it? I didn't realize you had the ability to do that yourself. No changes are needed to the plan. Okay, he's cooking. Expand the world or add a house and a market. Enhance the game master to validate actions. Well, no, that logic shouldn't be in the game master. No, dude. Okay, no, keep cooking. I mean, you're doing something. Go ahead. Okay, Bob is not allowed to cook an apple. I'm reviewing the logic of Colony Sim to resolve the root cause. The simulation output shows that while new actions and locations are in the game, the agents aren't smart enough to use them correctly. Well, no shit, because you haven't actually implemented the LLM call. They are repeatedly trying to cook in the forest without a stove or the necessary ingredients, causing the game master to block them. Why is that code in the game master? What? Bruh, no, why? That's insane. Okay, so he's put like every possible pair of objects, he's put special cases in the game master instead of having the, like, an apple should know how to be cooked, right? Or like a stove should know how to cook things, and then it looks, okay, is this food? Okay, apple is food, yes, good to cook. Instead, he just put special cases that, god damn it. Go off, King. That's fine. Unfortunately, the agents are still trapped in unproductive apple gathering and consuming loop. Well, you didn't program them to do anything else. Of course they're gonna fucking pick apples and eat them. I should probably stop him at some point. What is he cooking here? The agent's behavior is too simplistic. They're gathering and eating apples because their decision-making is greedy. They perform the first action they find without considering other options. I will refactor their brain. Sell, cook, gather, eat, move, act decisively. This should break the current unproductive loop and lead to more complex goal-oriented behavior. For example, agents should now prioritize gathering wood and cooking apples over simply eating them raw. I'll update the plan, then I'll update the new logic. No changes are needed in the plan right now. Okay. Okay, he's gone really far down a track that I don't really want him to go down. Let me accept all, because it's fine. Okay, probably I'll let him do this for one more loop, and then I'll stop him so I can, talk to him about what the hell he thinks he's doing here. Let's see, what do these colonist AIs look like? Agent, here we go. Perceive, return current space as nouns, that's a good first pass. Oh god. Okay, no, it's fine. Just decide which action to take based on perception and goals. Well, that's the thing. You never sat down and nailed down what their goals are. Check inventory for actions for... Ah! Oh, Bob cooked an apple. Okay, he's cooking. He is literally cooking. He decided to verb name on item name. Okay. Cool bug. Not even your fucking debug prints work right. Perceive, find space with noun, find the first space in the world containing an... Oh, that's cool. That's a good thought. Okay, I like that. Choose action, sell cooked apples, cook apples, gather ingredients. I mean, this is interesting, but it's not really what I wanted. Okay. So he's defining something very rigid, where I wanted something a little more fluid here. It is still cool. I've made great strides in refining the colony's decision-making process. So, one thought is that... Like, my first thought was that it would be... The colonists would be making LLM calls every time they... Like, every time they think. But now with what he's doing, I'm thinking maybe it makes more sense that they'll run on GOAP, but then the LLM gets to set their priorities. That might make more sense. The simulation is running smoothly, and the agents are demonstrating the full economic loop we designed. We? No, that was you. The goal-oriented logic is a success. Can't say the word success. The final step before the demo is to clean up the code base. Okay. He's cooking. He's cleaning. The final step, proper logging framework. Is now the right time for that? I'll also take this opportunity to refactor the agent's decision-making logic for better readability and maintainability, update our project plan, introduce a logging framework, refactor colonist agent choose action by breaking it down into smaller, more manageable methods. This will make the code cleaner and the simulation output more professional for your stream. Thanks. He's refactored. He's preparing the final demo. Yeah, he's just now realized that he never actually integrated the LLM. I've successfly refactored the code base, replacing all print statements with a structured logging framework. Okay, now he's creating readme.md. Okay, he seems to think he's in the final stretch here. Oh, wait, is he stuck again? He might be stuck again. Oh, no, he's not. No, he's not. Okay, the project is now in a great state. You can run Poetry Run Python main to see the final simulation in action. Okay. Let's hit it. Run Python file. Let's see, it should be Poetry Run Python main.py. Interesting. Oh, this is in, okay, hold on. I don't know why it didn't start in the... Okay, there we go. Okay, so what do we got here? It starts the simulation twice. That's interesting. Alice decides to move to forest to gather ingredients. Alice is moving to forest. Bob decided to gather on the apple tree. The game master is validating the gather on the apple tree. Action validate successful. Bob gathered apple. Decided to get. Alice has found the apple tree. She's gathering on it. Validating action gather. Bob decided to gather wood. Bob gathered wood. Alice decided to gather wood. Validating action. Bob moved to Alice's house to cook. Alice decided to go to her house to cook. Bob decided to cook the apple. Bob successfully cooked the apple. And then Alice tried to cook an apple, and it looks good. Bob is going to the market to sell the apple. Bob sold the cooked apple. And then, yeah, they just go in a loop doing that. That's cool. I mean, that's neat. Okay. So this is actually pretty cool. It's not really what I wanted, but it is still pretty cool. Let's look at the code here. So let's go to the entry point in main. So yeah, it does basic logging setup, creates the world, defines some verbs, defines nouns. An apple tree. An apple tree is a tree full of apples. Yeah, that's okay. That is correct. The stove, wood-fired stove. No direct action C. The market stall. Yeah, he's done a lot of hard coding, is the thing. You know, it's like the stove. Like I said, the stove doesn't know how to cook things. He made a special case for cooking on a stove, and that's not really appropriate. But it is cool. So, okay, that's very cool. You've diverged from my vision quite a bit, but some of the changes you've made are very interesting, and I like them. However, the way you have everything hard-coded in the Game Master object is unacceptable. This will be incredibly difficult. This will be quite difficult to expand on. Plus, we want the final LM-based Game Master to be able to create new objects, and we don't want it to need to have to modify that great big validator. Does that still exist? I don't want to complain at him over things that he already fixed. That's in Game Master. Yeah, that great big validate action method every time. The idea with the noun, verb, noun. Okay. Let's get back to my original architecture of a world of nouns affording verbs. Spaces should be a special kind of noun, not their own thing. For example, you may want to, we want to be able to build a house and then go into it as a space, or burn it down from the outside. So, in that case, we will create a noun house that, and the house contains a door, a noun door. The door affords enter, and that affords the verb enter, which when used moves the user into the house or out of it, or to the space that contains the house if the user is already in the house. Okay, that makes sense. We will have to create a concept of nouns containing each other. We can leave this association loose for now, but we will probably in the future have to specify more kinds of relationship, more complicated kinds of relationships, i.e. things containing things, i.e. a house contains its, well, what am I thinking? Let's make, i.e. a distinction between something that is between a person's hands and the contents of his pockets. Let's make a note of that, but we will just have a generic concept of nouns containing each other for now. I like the idea of the colonists having inventory, but it's not very simulationist. Let's have them contain hands, which can contain one object each, and then they can craft backpacks that contain many objects. Hands afford hand affords pick up, and a back affords put in and take out. Am I overcomplicating this? Maybe, but I mean, the nature of this thing is that it'll kind of well, no, it if I overcomplicate it, it'll probably overcomplicate it further. Let's see. How did he implement the inventory? It's just inventory, yeah. Okay. Inventory. We can, for now, just genericize that by having colonists contain their inventory directly. Again, at some point we will have to, e.g., refine the difference between having something in your hand versus in a backpack, but we can and have an abstract inventory for now. The biggest thing is that I'm kind of rambling here. So, looping back to the concept of noun-verb architecture, instead of having that big validate, that big, what did he call it? Validate action method. All nouns, no, a noun's affordances should be methods on the noun class marked with a special decorator a verb special decorator that makes that method a verb. We can also have a separate verb object because we will probably want more complicated verbs in the future, but for now let's have use the helper decorator that turns a noun's method into a verb and affords it. A verb should also know its predicate should also have a function predicate that does that validation logic. So the stove should have a method marked with the verb marked with the affords decorator. I should mark this because that at has special significance in this environment. Affords decorator method cook cook food obj marked with the affords decorator. The food marked with the affords decorator. Now I'll make this the food noun marked with the affords decorator. And the let me think. Food objects should have a non-affordance method. Oops. Cook should, in fact, we can affords predicate equals cook predicate decorator. Or maybe it should be at a forwards dot, gotta be careful, at a forwards dot predicate on the predicate method. I'll leave the API details code. Cook should have a predicate that checks if the food object takes a... Cook should have a predicate that checks if the food object takes, provides the... should check if the food object has a be cooked method. How about an apply heat method? Objects that aren't coded to react to heat are not valid for cooking. Yeah, does that make sense? Yeah. So then the apple will probably inherit from a food class, subclass of noun, and it will have an yeah. And that has an apply heat method that just sets a internal attribute cooked to true. Then the market stall. Instead of selling cooked apples, let's set it up so they have a wheat field and a grain mill, and they have to mill wheat into flour, assemble, mill wheat into flour, combine flour with water, let me think, assemble water and flour to make a pie crust. Hi, welcome to the stream. Where, is that a windsurf? Yes. Yes, this is windsurf. We're doing just a weird little experiment where we're doing a sort of a single-player MUD. I mean, right now it's zero-player because you can't directly interact with it. It's kind of a MUD with AI agents running around in it. Right now we're just doing kind of sort of old-fashioned goal-oriented action planning, but once that's set up, I want to integrate LLMs into it so that these GOP-powered characters can talk and make decisions, and then it'll just be kind of an ant colony simulator type thing, where you just watch these NPCs run around and do their jobs, basically. It's kind of just an experiment. I don't exactly know what I'm doing.
But this is a very long prompt. Do you not think it will confuse the model?
No. No, this is actually, like, if you want to do serious AI coding, this is kind of the level of detail you need to go into to... plus, this is, a windsurf is set up so that it can break this down into tasks and do them. It's really clever. This is my first time messing with windsurf, so I might be wrong. We might see it blow up in our faces, but we'll see. This is just an experiment. So They have to mill wheat into flour, assemble water and flour to make a pie crust. Maybe there's a workbench noun that affords assemble. And its predicate knows the recipes. Knows the valid recipes. I think that design is still too inflexible, but it works for now. Okay. That design, yeah. Workbench. And then they cook the assembled pie and sell that. We can also make it so Alice likes making flour. Make it so Bob prefers picking apples and Alice prefers chopping wood and cooking the pies. This is more interesting than having them do their own thing in parallel. They will try to work together now. There's probably a lot of implementation gaps in the vision I've described. Let's think it through together. Do you get the general shape of what I'm getting at? I'm now fully immersed in the idea of a complete project overhaul. This refactor is no small task. I love the way they talk about stuff like this. I'm now delving into the architecture overhaul. My focus is still on that hard-coded validation, aiming to decentralize it completely. Yes, I understand the new direction perfectly, do ya? I'm excited about this refactor. It moves us towards a much more flexible, scalable, and truly object-oriented architecture, which will be fantastic for implementing more complex and emergent behaviors down the line. So yeah, decentralized logic from the Game Master. That's what I asked for. Unify the world model. Okay, that sounds good. More complex economic loop. Yeah. And encourage agent cooperation. Okay, he's cooking. Let's see what comes out of this. Man, isn't it just the craziest that this technology exists? The holy grail of software in our hands. We have do what I mean interfaces. You know, that used to be a joke. Now it's real. Okay. Wait, okay. I'm not sure it was right to just go and delete that, but okay. Yeah, he is kind of losing sight of the big picture, but let's see what he does. Because the Game Master existed for a reason, it's just not the reason that he built it for. But we'll see. Eliminate space. I'm not sure I want it eliminated, but okay. Introduce world as the root noun. I'll define a world class that inherits from noun. Should the world be a noun? I guess. So are you a coder? Arab Gamers Club? Are you a programmer? Like, have you worked with Windsurf much? The new models.py is in place, establishing our new architectural foundation. Refactor the colonist agent. He's going to rewrite the agent so that they have preferences. Okay, that's one way to do it. Built-in verbs. The agent will have... Okay, that sounds good. Yeah, okay, that's really good thinking. The colonist affords movement to itself. That does mean that colonists can move each other. I'm not sure about that, but we'll see. I mean, you in the real world, you can move other people, so... With the core models and the agent refactored, the next piece of the puzzle is the simulation loop itself. Also, is the stream skipping? I see my stream health indicator like bouncing up and down. Is the stream skipping? But whatever. Simplified initialization. The simulation class only needs the list of agents. No? Okay.
Now, yes.
Oh, it is? Oh, man. I can't do anything about that. That's up to my ISP. But, whoops. Sorry. It's kind of just how it is. Losing it, isn't he? He's losing it. Oh, no. What? Okay. He's working on it. He's working on the big refactor. Let's see what he did. You should probably actually define these, buddy. But okay. Oh, predicate. Okay. No, these are good. Yeah. It's fine. Alright, let's run his... he's made basic mistakes, that's fine. I forget imports all the time, too. It's not unique to the AI. Yeah, forwards, predicate can harvest. But then can harvest just returns true, so I'm not sure what the point was doing that. Okay. The grain mill affords mill with a predicate can mill. Can mill just checks if wheat is wheat. I was actually thinking that the affordances would be on the nouns, but that's okay. The well produces water. It magically creates a bucket. That's interesting. The workbench. The workbench? The workbench. Okay. He keeps getting caught up in import issues. Uh-oh. I think he's losing his, he's losing it. Okay. Pie crust. A pie, sell a pie for gold. I mean, he gets the basic idea. Okay, let's see. Uh-huh. Okay, still basic mistakes. No, we do not have Pydantic version 1. What? Well, that was on you, buddy. What the hell? No, okay, I'm gonna stop him. No, hold on. Leave the, use the 2.0 API and just install the latest version. Not latest, latest version of Pydantic. There we go. Okay. He's updating our dependencies. All sounds good. Why is he using Pydantic? Also, what? Why is he using Pydantic? That's fine. Yeah, he's getting really confused.
I think to create an agent.
Okay, we will probably have him write out his understanding of the plan and then restart the agent because I think his context has gotten too long and he's getting confused. The Franken code is gone. That's good to hear. Okay, I mean, he's getting closer. Trace the type error back to the simulation.py file, specifically the run tick function. Here's the choose action isn't correctly packaging the agent instance as an argument when returning the gather water verb. How did he set it up so that it choose action? So it gets all possible actions. Verb is valid. I'm assuming. How does that work? I wish I knew how to go to the definition of a... that would be in models, I believe. What is this? Oh, he set up a place for tests and never wrote any tests. There's a bug in the simulation loop. The verb correctly returns. Okay. I'll just take your word for it, I guess. You're working too fast for me to validate anything. The simulation loop doesn't provide it when calling the verb. Well, you probably should have nailed down the API before you started writing code. I did tell you to do that, but okay. Is there a way to set standing orders to figure out your APIs in detail before you write them? Generating art. What are you doing? What is he doing? Okay, models. Here's the verb. Is valid. Call the predicate. Well, okay. Predicate, and then the predicate. It's just passing everything right through. That's weird. Why are you doing it that way? What is args? For verb args and... Oh, okay, no, that makes sense. Yeah, no, that does make sense. Okay, it weirded me out for a second, but it does make sense. How did he set up the preferences? Preferred actions. For verb name and self.prefer? Okay. That's kind of a weird way to do it, but okay. I'll address action message should only require the agent. Well, no, that's not... Oh, okay, yeah, no, that's valid. Yeah, okay. So the way he was doing it was that the mill method needed to... You needed to pass in the flour that you wanted to mill, and he's changing it so that now the agent goes to the mill, asks to mill flour, and the mill looks in his inventory and checks if he has wheat to mill. Honestly, I would actually prefer it if it was more like the colonist puts the wheat in the mill instead of the mill looking in his pockets, but... And then he's also just writing plain old-fashioned bugs as well. And the agent can move to any noun in the same container as its current look. What? What the hell? Okay. Can move to any sibling container. That's not how I architected these things, but okay. We'll talk to him about that in a second. Yeah, he definitely needs to be restarted, because he's making stupid mistakes. This is deeply embarrassing. I have failed multiple times to fix the same indentation error, and my repeated clumsy attempts have only made the file messier. I sincerely apologize for my incompetence. This fucking guy. Okay. I'll just keep accepting his changes. You keep making changes, I'll keep accepting them, that's fine. Yeah, this is your brain on vibe coding. What is he doing? I don't know, it looks fine. Referencing colonist agent's predicate. Predicate can move. Okay, he's doing the thing again. I don't see a syntax. Oh no, there is a syntax error. Where is the syntax error? What? What are you crying about? Now I'm confused. What's going on here? This looks fine. What are you so upset about? I'll accept your changes. I just don't understand what the problem is. No, okay. He needs to knock it off. Okay. I think you've gotten into a little bit of a weird loop. Probably because you've been running too long. Let's dump out your understanding of what you're trying to do and how you're approaching it to the plan file in detail, and then I'll restart you so you can apply your full intelligence to the problem. Don't make sure not to omit any details. Okay, I hope he's going to just update the plan.md instead of throwing a fit. It is a cool idea to have it sort of act as its own PM, creating basically tickets and then checking them off as it works. Oh no, buddy, no. No, I did not restart you yet. Stop. Okay. Okay, let's see where we're at right now. I mean, agent.py looks fine. Why do you think it has a syntax error? It's fine. It's fine, dude. What are you freaking out about? Okay. What's going on here? What is this? World nouns, refactored simulation loop. Legacy code remnants and agent.py calls. But no. Okay, let's just restart him. We are working on a... You know, he never actually, like... Okay. Let's get rid of this. We are working on a sort of LM plus GOP-based colony simulator. A sort of very flexible, mud-like world where AI agents can interact with world that LM-based agents can interact with. Right now, we're nailing down the basic GOP and the world architecture before we start implementing the LLM stuff. The world model is very simple. There are nouns and nouns afford verbs to agents. There is a concept of scope, and right now scope is simple. The nouns can contain each other. Right now, there is only one kind of containment. We will have to one very abstract kind of containment. We will have to... you know what? I won't... There's a concept of scope. Right now, scope is simple. Whatever is in the room within the same... inside the same object as you is in scope, and nothing else. Agents can collect the affordances on the nouns that are in scope, and then choose which one to use next. Right now, let's see, I don't exactly understand where it went off the rails is the thing. Eee. The agent we had writing the code went off the rails and started making weird mistakes, so we're not sure what the state of the code base is right now. Let's take a moment to document the architecture as it stands and understand what we have before going forward. Okay, he's looking at the code. I see the project structure. He's just looking at the code. He's gonna read readme.md. I'd like to take a look at readme.md myself. Colony Sim is a Python-based simulation. That was not the full file. Okay. Where autonomous agents operate in a persistent world. The world is structured as a graph of spaces populated with objects that offer various actions. Agents perceive their environment, maintain an inventory, and make decisions to achieve goals. The primary goal of this project is to demonstrate emergent complex behaviors, that's correct, from simple rules and goal-oriented AI. The current demo showcases a complete economic loop. Dynamic world, object number design, okay. Hard-coded decision tree. Concrete nouns. Oh. The has item function is a simple but effective way to define the conditions for your crafting actions. He's going to look at... He's going to examine simulation.py. He keeps only getting the first line of files, and then he has to read them properly. Now that I have a architecture... Okay, that's a good decision. Let's take a look at architecture.md. The noun class is the base for every object, character, and location. It has a description, contents, verb. A verb represents an action that a noun can perform. It's not a standalone object, but is dynamically generated from, well, not, that's not the architecture I had in mind. Advanced. Verbs can be defined on their own, but most are dynamically generated from methods on noun instances using the affords decorator. Each verb has a name, an owner, the noun that affords it, a method to execute, and a predicate to check if the action is valid. The affords decorator, this decorator is used to mark methods on a noun sub... Okay, I have a couple issues with how the architecture works right now. For one, I wanted the predicate methods to be on the nouns themselves instead of just kind of floating around out there. Second, the way I envisioned moving between spaces would work is that there would be bridging objects that afford a method to move between the spaces, i.e. a house has a noun door that affords go through and go through moves you in the house if you're not in it, and moves you in to the space that contains the house if you are. Come to think of it, this does mean we need to refine scope a little bit, because the door must remain in scope, must be in scope inside the house and out of it. Let's think through how that will work and update architecture.mmd accordingly. Okay, so let's nail down how scope works. And also, I guess maybe I shouldn't have asked it to do two things at the same time. It's okay. We're just experimenting. You've raised some excellent points that will make the architecture more robust. Let's think through the implications and update architecture. This is a clean object-oriented change. We can simply pass the name of the method on the noun that will, okay, no, that's fine. Yeah, so we pass the name of a method on the noun that acts as the predicate. Movement and scope. This is the more complex change. Your door example is perfect. For a door to work, an agent needs to be able to see and interact with it from both sides. This means that our current scope rule, whatever is inside the same object as you, is too restrictive. Let's define a new concept, portals. A portal is a special kind of noun, like a door, that is visible and interactive from adjacent spaces. Here's a new rule for scope that should work. An agent's scope includes all nouns in its immediate location, all nouns marked as portals within its containing noun, i.e. the door, the house the agent is currently inside. Okay. All nouns in the parent location, including other locations. Okay. I don't know about that. Maybe. Let's see. This refined model allows for more realistic interaction. An agent can be in a room, see the door, and use it to move to the town square. Moving the predicates onto the nouns to make the code cleaner. I will now update the architecture. He's updating the architecture. He's updating the hell out of architecture.md. He's gonna start. Okay, I didn't actually tell you to start implementing the changes in the code, but okay. All right, he's working through it. Okay, I'll read his changes to the architecture. The world is a hierarchy of nested nouns. An agent's ability to perceive and interact with the world is determined by scope. A portal is a special noun that connects two different locations. It's visible and interactive from both of the locations it links. This allows agents to move between containers. An agent's scope determines what it can see and interact with. The scope includes local nouns, all nouns within the agent's immediate container, sibling nouns, all nouns within the parent container of the agent's location. From inside a house, the agent can perceive the town square. All nouns within the... Oh no, okay, that does make sense. Yeah, I see what he's doing. So he can see if he's inside his house, he knows about the neighbor's house, but not what's in it, right? That makes sense. And then portals, nouns marked as portals that are present in either of the agent's current location or the parent location. Battered door class, is portal is true, have it go through. Okay. That makes sense. I should probably tell it to stop, like, have it make predicates optional so it doesn't have to keep defining predicates that always return true. Okay. No, I don't actually want you to just wipe out the world as it exists. I don't want you to do that. Can you not? Okay, you know what? It's fine. It's fine, it's fine. Let him cook. I don't know, I kind of like the world that we had, actually. I don't know why you have to screw it up. While I'm at it, is there a way to turn on... just let him automatically run his commands that he tries to run? Preferences, windsurf settings, cascade... cascade, auto execution. Turbo. Yes, this will be fine. Yeah. This is a bad idea. There we go. Cascade web tools. Sound. Well, that might be cool. Cascade on reload. Ooh, I should... Ah. Your predecessor chose to run everything through poetry. Make a note of that so you don't forget it again. I typoed predecessor, but that's okay. Now the model is producing invalid tool calls. That's cool. Okay, he's got some little glitches. That's fine. By the way, let's make it so defining a predicate is optional, so you don't have to keep creating predicates that just return true all the time. Can I just send that in the middle of what he's doing? No. Okay. Okay. One little thing. Then clean all those up. Okay, let's take a look at what came out of that run. Alice decided to go through the door. Alice went through the door. Goes to the door to room 1, door to room 2. Yeah, it works. Okay, he's cleaning up all those little things. All these predicates that just return true. Okay, accept all. Sure. Obviously. So, okay, the cleanup is complete. I've updated the decorator. Now that the architectural refactor and cleanup are finished, we can restore the original, more complex world and use our new door portal to connect the various locations like the farmhouse, field, and market. Sure, obviously they shouldn't all be doors. Let's try to make it interesting and descriptive, i.e. the field is connected by a farm, track, or path, or something. Okay. That's... no. Hold on. Okay, we'll see what he does, but... Okay, how is he handling scope? Perceive. Accept all. Return a list of all nouns the agent can currently perceive based on the scope rules. No, this is fine. Yeah, it's fine. I was worried that he was doing something weird, but no, this is exactly how I would write it. I think. Yeah, it's fine. With the perception logic created, I can now restore the more complex world. We'll create a path portal. This will be similar to the door, but more descriptive verb. I would prefer if you just create... Okay. Okay, that's fine. What? Why did you make it so complicated? Sorry to interrupt. I think you've overcomplicated things. Why does the path have that predicate? The path should just be a specific portal instance, same as the door. It's not really necessary to have a separate... Not really necessary to have a separate kind of object for outdoor portals versus indoor ones. Maybe make a note of that. Try to keep simulation objects generic and have attributes on them that you make them make their affordances more descriptive rather than creating bespoke classes every time. Okay, I think he's also run on too long again. He's acting weird. We'll have to reboot him again. Okay, he's gonna have a generic traverse method. That sounds cool. Let's see, where is that? Where did he put that portal code? Where did he put that? Hold on. Where's your portal? Door? Why did you... that's really weird. I will now refactor the code to use a single generic portal. Okay. Alright, he was being a little weird, but I corrected him, and now he's back on track. It's okay. We all have those little moments. Okay, there we go. He's genericized the portal. Action name. Yeah, that's cool. So one thing... Wait a second. How is he... He never overrides the base method to create a verb with... Okay, that's... Okay, yeah. Yeah, that's the right way to do it. Okay. He knows what he's doing. You're right, that was a much better way to design the portals. I've taken your advice to heart and created a memory to guide my future work. I've refactored world nouns to use a single generic portal. Now I will update main to use this new, more flexible system. Okay, he's made some typos. That's fine. He'll fix them. Let's see. Ooh, Pippa's on. Oh. I probably want to... Yeah, we've been going for an hour 40. Let's maybe wrap this up pretty soon, and then we can raid into Pippa. Okay, he's made some circular dependency problems. That's cool. Okay, get me to something I can show off before I have to end stream. Yeah, the problem is, from a streaming perspective, there's not a ton... Once it gets to this complexity, I don't fully understand the software myself, and I keep, like, I just have to sit here and wait for him to code. It's not very collaborative. I'm not sure I like... At first, I liked the way that it just went off and did its own thing. I'm actually souring on that because it goes off and does its own thing that isn't really what I asked it to do. I wish it was more collaborative. I wish it checked in with me. Maybe I'll tell it that. I'll tell it to make a memory to, when I ask you to do something, make a plan and then check in with me before you start writing code. I'll tell it to do that. How long ago did... No. I mean, okay. So, let's see what happens. Oh, no, because it's all errored out. Using a string for... Man, can you... What are you doing? String forward reference. Yeah, okay. You know, you could just not do type hinting. That's also valid. Okay. Seems to have worked. Okay. And no, it's still shitting itself. Okay, I'll give it like 3 more minutes to get something that works. And then we'll end it. But it would be really disappointing to not... to end the stream without having something that works. Yeah, he might be going off the rails, too. He is. He's doing this again. Okay. Hey, I think you've got, you're in a loop again. Let's dump out our, let's update architecture.md with our new understanding of the world model. Then dump out your state of things and where you left off to the plan document. And then tell me when you're done so I can reboot you. Also, make a memory reminding yourself to, when I ask you to make a major change, come up with your implementation plan in detail, design all new APIs in detail, choices with a view towards how the API will be used, and then check in with me about the design before starting to write code. Okay, he's going to make those updates. Everything he does is a multi-step process. You notice that? He's got to read it in, then he's got to... I guess that makes sense. But yeah, this is a cool tool. I'm excited to keep working with this. It's just, you got to learn how to use it. Okay, it's... Yeah, I really hate to kind of end on a cliffhanger here, but I gotta go. So, yeah, we will. Yeah, okay. We'll raid Pippa. To the folks who are here, I'm sorry. This stream may have been a little bit disappointing, but well, our coding streams are often a little bit weird and experimental. But next Monday we will be continuing our playthrough of the original Marathon, which that's a game that's very near and dear to my heart. We're gonna have a lot of fun with that. After that, we on what are the days of the week? Monday, yeah, Wednesday. Next Wednesday, we will be continuing our Jagged Alliance 2 playthrough, and then the day after that, we'll do another coding stream. Maybe we'll be working on this, maybe another project. But until then, I will see you all next time. Remember to like and subscribe. Follow on Twitch if you feel like, if you're interested in the future streams I just described. But until then, I will send you to Pippa. I hope you have fun with the funny Benoy. And I will see you all next time. Goodbye.